everyone. Let's dive into support vector machines, or also called as SVMs, a powerful supervised learning algorithm used widely in machine learning tasks. So, SVM is a supervised machine learning algorithm that primarily used for classification, but it can also handle regression problems. The key idea behind SVM is to find the optimal hyperplane that best separates different classes in the data. It performs particular well with small to medium sized data sets that have clear class boundaries, and also the algorithms works by maximizing the margin between classes. So this margin is the space between the decision boundary and the closest data points from each class. So the key concepts behind SVM is they are generally the data points that are closest to the decision boundary. They are critically because directly influence the position of the hyperplane. So generally the hyperplane is a line or surface that separates the classes in 2D. It's a line. In a higher dimension, it is a plane or also known as hyperplane. So in normal classes, I mean, if it is a 2D class, then it is called as a line. And if it is in a higher dimension, that means like a 3D class, then it is called as a hyperplane. Margin is the distance between the hyperplane and the support vectors. A larger margin generally means better and generalization. So there is a Hing loss, which is also known as a loss function. It penalizes incorrect predictions or normal predictions that fall too close to the margin, helping to create a more robust model. So, mathematical objective. So, the main goal of the SVM is to maximize the margin between classes while minimizing the classification error. Mathematically, this is framed as minimizing an objective function made up of two components: a regularization term that helps to avoid overfitting, the Hing loss, which handles prediction. So we typically use gradient descent to optimize the objective function. When a data point is correctly satisfied, then the model is updated only with the regularization term. So if the point is misclassified, both the Hing loss and regularization are used to update the weights. So support vector machine in Python are used to implement uh, let us consider an example called as lung cancer from the Wisconsin dataset. Here are the key steps in the workflow. It generally takes the pre-processing, which converts the labels into binary form and remove unnecessary columns. Then it splits the dataset into 70% of training and 30% of testing. Then the skit-learn, which is used in SVC class with a linear kernel to train the model. Kernels are the minuscule models. And finally, we evaluate the model using the accuracy and the confusion matrix to understand how well it is performed. So, in the conclusion, it is highly effective for binary classification, especially when classes are clearly separated. So, it performs best on smaller dataset, and it's relatively simple to implement using libraries like skitlearn. Overall, SVMs are fast, robust, and often high accurate, making them a strong choice for many classification tasks. Now, I'll move on to the Google Colab notebook, where I'll walk through the actual Python code and show you the results in step by step. So, as we already know, SVMs are versatile and are used in many areas like classification, regression, outlier detection, and clustering. They work especially when the number of features is high and the dataset is too large. So, generally, how does SVM compared to other machine learning models work? Well, it works with smaller dataset and with less noise in the sense errors. So in constant models like random forest or deep neural networks needed more data, but offer more flexibility. Always choose your algorithm based on your data and specific problem. So generally SVM is a supervised machine learning algorithm that I already said. That means we have to train it on labeled data. It is mainly used for classification, though it can do regression too. The main idea is simple. It finds the best boundary, called as a hyperplane, that separates different classes of data. The most important data points in an SVM are called support vectors. These are data points that lie closest to the decision boundary. So why are they important? They are important because they define the position and orientation of the hyperplane, and remove them and the model would change. If you remove them, then the model would change. So a hyperplane is just a decision boundary. In 2D it is called as a lane, in 3D it is called as a plane. In other higher dimensions it is also called as hyperplane or subspace. Okay, so its job is to separate the classes in a feature space. When training an SVM, we want to penalize misclassification. For that, we use a special loss function called as Hing loss. So this is the formula for Hing loss, where the function ensures that correct prediction are far from the boundary and incorrect ones are penalized. Generally, the SVM objective has two parts: the regularization term and the loss term. So the regularization term is like keeps the decision boundaries as far as possible from the data, and the loss term ensures the model classified correctly. And the total objective is to maximize the margin while minimizing the classification errors. So let me explain you the step-by-step code. In the first one, we imported the necessary libraries, pandas for data handling, test, train, split to split our dataset, SVC from sklearn to create our SVM model, and matplot libraries are used to visualize the data. Now we load the dataset directly from the GitHub URL. So this dataset contains tumor features and diagnosis labels. So we convert labels like malignant is equal to 1, binning is equal to 2. We also drop unnecessary columns like ID and unnamed fields. So now we create a readable labeled column to help us to understand the data when we plot it. So here is a visualization two features, radius and texture. So generally works like a scatter plot, which shows how the classes are spread out. We separate the data into features like X and Y labels. Then we split the data into training and testing models, where it takes 70% of training and 30% of testing. Okay, and now we can create the and train the linear SVM model using SVC. So here the kernel is equal to linear tells the model to use straight line or a plane to separate the classes. So we use a trained model to predict the labels for our test set, and then we calculate the accuracy, how many predictions were correct. We print the confusion matrix finally, so that to understand how well that the model is performed in detail. So I'll also provide you the link to recheck the entire code. And finally, we display the size of test set and the final accuracy percentage. So what we have learned today is what an SVM is, how it finds the best decision boundary, the role of support vectors, hyperplanes, and Hing loss, and finally, how to implement it on real data using sklearn. So thanks for sticking around and a happy coding.